Okay, so hopefully everyone had a good time building their little domino animation. It's one of the things that I've learned about working inside of any animation package is that practice makes perfect. It really is. It's kind of one of the most important parts of kind of our workflow. You have to get in, you have to build stuff, you have to get your hands dirty in order to really understand the sequence and the steps and how all this technology works together. This is not one of those things that you can just kind of learn by watching someone else do it. You got to jump in and do it yourselves, right? So we're going to be doing a lot of these little mini animations over the next couple of weeks. Starting today, we're really going to kind of be tackling two different things at the exact same time. Starting today, we're going to start working on our final project, okay? Now, this is the end of week 9. We kind of sit oddly inside of the academic schedule. These Friday afternoon classes kind of present some challenges to us, especially if you start looking forward into next month, right? What happens for this class in the month of November? Does anyone know? Thanksgiving and Veterans Day. Okay, so in the month of Thanksgiving, we have 2 Friday holidays this season, okay? So we have to start rocking and rolling on our final project, and all honesty, right about now, to make sure that we give it its due diligence and its production time so that we can produce something of value, okay? So starting today, we're going to start working on our final project, okay? And we're going to start conceptualizing what this final project is going to be. Now, I need to make a deal with you, okay? I'm going to give you time in the academic school year, okay, in the semester, to work on your final project, okay? But you have to work on it starting now, okay? And I'm going to kind of force you guys to do this as well, because we're going to kind of step through this process with a whole series of mini milestones. As you can see from our homework, our mini milestone that we're striving to accomplish between now and next week is to come up with a concept and then produce a whole series of very rough storyboards for that concept, okay? Your final project in this class is going to be an animation, a story of your choosing that's going to be at least 30 seconds long. A story that has a beginning, a middle, and an end. A story that has some character, and it could be it could be a physical, upright, bipedal character, as literal as we can make it, or it can be something as abstract as you'd like it to be, like a cube. Last semester, someone did a really great car story, okay? So I'm going to let you figure out what the character is, but this character needs to have some sort of problem or dilemma, something that they need to resolve at the end of their story, right? There needs to be something that this character is trying to overcome or do within the story. So this isn't just like a 30-second cool animation of some dominoes falling on the ground. That's not the whole purpose of this, right? The purpose is to tell a narrative, to take an audience member from, through the beginning, through the climax and resolution, and then to meet some sort of natural conclusion at the end, okay? Now, crafting stories and getting us to the point where we can render something that's going to have some weight and value is going to take some energy. That's why we're going to kind of step through it one milestone at a time. The first milestone is kind of the most difficult one. It's just coming up with a crazy idea, right? That's actually, honestly, the most difficult part, okay? And then we're going to start visualizing that idea. What are the characters? What are the sets? What are these at the end of this sequence? What type of emotional roller coaster are we hoping our audience members to go on? All questions that we're going to try to answer over the next 7 days as we conceptualize what our story is and then begin to actually visualize it with some storyboards, okay? Now, these storyboards you're going to share with the rest of the class, okay? So come next week prepared to share your storyboards. You're going to talk us through them. I want you to try to focus as much as you can on trying to create a story that doesn't include a lot of dialogue, okay? Dialogue is tough, okay? If we can hold our audience's attention without dialogue, then we have something that's pretty good, okay? So let's try real hard to have as little dialogue as possible. Often what happens is that people put too much emphasis on the dialogue and they try to tell the story entirely through the dialogue, and that's not what we're in the business of doing, right? We want to visualize a story. We want to try to visually, through the movements of our animated characters, tell a story, okay? So as little dialogue as you possibly can. Is this tough? Yeah, absolutely, right? but it forces us to be animators, okay? Questions on, and I may have kind of alluded to this, and I apologize for not saying it directly. This can literally be anything you want, okay? It can be any story in any setting, in any environment, with any characters. However, ... please keep in mind that you're going to be building this thing, okay? That you're going to be animating these characters, that you're going to be coming up with all the sets, doing all the animation, the rigging, the rendering, everything. We're going to baby step through it, okay? We don't have 2 weeks to pop this thing out. We have a couple months, right? And if we start working on it now, this is absolutely a very doable project, okay? In every sense, this final project is kind of what we're here to do, right? Everything has been building to this one moment inside of our program, okay? At the end of this, we're storytellers, we're actors. We have something that we want to communicate to our audience. This is that opportunity to communicate that idea, okay? So do some soul searching, do some thinking this week. Come up with something that you're really excited about, because you're going to be living with this project for the next 2 months, basically, okay? So this is going to be due on December 15th, which is the very, very last day of the fall semester. 30 seconds. 30 seconds, okay? It can be longer, but I would really, really recommend that you shoot for 30 seconds, okay? 30 seconds seems like a blink of an eye, but when it comes to, animating and rendering, 30 seconds turns into a Herculean effort pretty quickly. How many frames are you going to have to render for a 30-second animation? Say again? 720. 720, right? 720 frames, okay? That's a lot of frames. It really is, okay? So we want to make sure that we're not biting off more than we can chew. Yes, sir? We'll talk about the delivery of that at the very end. That's called pre and post roll. In certain situations, having pre and post roll is a really great idea, but that's not really the body of this assignment, right? So don't worry about it. That's a technical detail that we can handle on December 14th, establishing that pre and post roll. Other questions about what the final project is going to be in here? Okay, there's going to be more details come out on the final project as we get closer. I've learned from doing this in the past that if I was to drop all the details now, those details in every sense begin to limit your idea. And I want you at this stage to be as creative as you can. I don't want you to think about the technical limitations or what the technical expectations are for this project yet. That will come, okay? I want you to really think conceptually about this. I want you to come up with a creative story that's going to be fun to visualize and something that you're into, okay? You're going to be living with this thing for basically almost the next 2 months, okay? If you don't like this, you're going to hate this project, okay? So come up with something fun. Every one of you guys has a passion. You came to my doorsteps for a reason. Remember that passion, okay? And use that as the driver for your final project, okay? My suggestions is to, keep your expectations in check, okay? You're not going to be making Star Wars in 2 months by yourself, okay? You're not going to be able to do something incredibly grandiose. Keep it small, keep it intimate, keep it focused on 1 or 2 characters, okay? Don't try to make it overly complex. Simple stories are the best stories, okay? We're going to be looking and refining your stories as we go through this process, okay? Every single one of us in here is going to give you guys an opportunity to get some feedback from your peers. Next week is that first round of feedback, okay? This is going to be a process where we refine the story. No story is perfect the first time out of the gate, okay? It is a tough process to go through because you have this idea, but then you have to remember that we are creating something for an audience member. It's our idea, but we have to keep the person that's going to be watching this in the foreground of our decision-making process, right? Because if our audience doesn't understand what the hell it is that we're trying to do, then it's mission failure, right? This is not about us. Okay, filmmaking is a very selfless kind of art form. It's not necessarily about us. It's okay to produce a perspective, and it's okay to communicate your idea and your vision of whatever it is. That's good. We have to do it in a way that our audience understands it. Okay, and that's going to be a process that we're going to go through, a process of refinement. Okay. After we do our storyboards, the next thing that you're going to love and hate is the generation of an animatic, okay? Because storyboards do a really great job of visualizing the sequence. But what do they do a very bad job of? Timing. How long is a shot? How long are we going to be looking at this person in comparison to the next person? The animatics are really going to give us an opportunity to really make the film, but at the lowest resolution possible. Okay? Next week, we're going to spend pretty much a big chunk of our time just talking about animatics and how we can make animatics and the process that we're going to go through to make animatics. And if we do it intelligently, in every sense, we can start setting up the structure for the final models and the final animations that will show up in the final film. Okay? The 3D animation film pipeline is a process of many, 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 many iterations. Okay, this animatic is the most important part of the pre-production stage because it's our first total visualization from A to Z as to what this thing could potentially look like and how long it's going to be. You're going to hate making an animatic because in every sense you're going to feel like you're going to be redoing your work in 3 weeks from now. Okay? But you're not, right? We want to keep it loosey-goosey. We want to keep it basic and rough so that when I make a suggestion, not if I make a suggestion, when I make a suggestion that will hopefully make this shot or sequence better, we can very quickly visualize that, make the changes without having to render 8,000 polygons and all this jazz. It's supposed to be a quick, rough way to get to a more solid understanding of what the end result's going to be. We're going to do an animatic for the entire film, okay? And I'm not going to let you advance on until you make an animatic for your entire film, okay? Because how could you animate something at the end if you don't even know at the beginning what you're animating, right? And in every sense, this animatic is going to be the master blueprint for your animation, okay? Make sense? Okay, and then after I say thumbs up on your animatic, then we're going to start working on creating high resolution models, high resolution animations. We'll talk about rendering, and we're even going to do some little basic video editing over in Premiere Pro as we kind of roll through the month of November in preparation of throwing all this stuff together at the end to make a film. Okay? Sound good? Everyone on board? Kind of understanding it? Now this is going to take some commitment from you guys, okay? You're going to have to work on this every single week. If you try to do this in the month of December, you are going to fail, okay? Not with a letter grade F from me, but just in that you just can't do this. This is an impossible task to do in 2 weeks, okay? Make sense? Okay, cool. Am I scaring people? I feel as though I'm kind of scaring folks a little bit. But it's something we have to work on. These things just don't kind of pop out, right? This is a long, laborious art form, right? It's very slow, okay? We got to start this process now. Now, to help you guys out with your storyboards, I've given you guys some storyboard templates. You're free to make your storyboards however that you'd want. If you want to make them, digitally, that's great. If you want to print some of these storyboard templates out and draw them out on hand, that's fine too. I don't care. Just bring your storyboards with you next week to class, okay? Because all of us are going to look at them together, okay? And we're going to make some revisions. We're going to make some changes. And you're going to communicate your idea to the rest of the class. And if we don't understand it, then we need to make some changes, okay? Because we're your audience to a certain degree, right? So use these as a good start. I think all of these links are just PDFs. You can bring those over into Photoshop and draw on top of them and start working. That's fine, okay? However you choose to make your storyboards is good with me. Questions on what we're going to be doing over the next 7 days as far as your homework goes? Yeah, everyone good? Everyone kind of understanding it? Okay, cool. Well, with that said, let's have some fun. Now, we were doing some hard surface stuff with the little dominoes before class. Just hold on to that project. That's just for you guys, just kind of practice for us. I have another one that I thought might be kind of fun to show you guys some soft surface dynamics. We looked a little bit at this last week. If you jump on into the week 9 area of D2L, you can quickly find, let's go in there real fast. I've given you guys this cool little flagpole scene. Okay? Go ahead and download this, unarchive it, and open up the Luxology project file. It's a pretty easy or simple scene. There it is. Pretty basic. Just a flag. I want to show you guys how to make soft surface dynamics, and then I'm going to show you some shattering stuff too, which I think you guys will like. All right. Does everyone have this file open? Because we're going to make this flag flap in the wind, which is kind of fun. I like your flag, Alex. You just knocked out some pixel art there. I love it. Might have a picture on it, right? Now you're making me want to put a picture on there or something. Okay, here we go. Alex just threw down the gauntlet, so I got to respond. Okay. Now I don't think this is going to show up, but let's find out. I don't know. Let's just make a new material for the flag. And over in our shader tree, I think I have an image on my desktop still that I can use. Yeah, here we go. Okay, boom, I'm done. There we go. Now we have a GCOM flag. There it is. Nice, right? Yeah. Boom! Gauntlet throwdown. Okay, so the goal here is to get our little flag moving. Now, we still want to use our dynamic system to create a compelling animation for this, right? This is absolutely not something that you'd want to have to try to do by hand, right? Because how would you even approach this by hand? You don't want to rig a flag animation, right, with some bones. That'd be kind of silly. No way, man. What we can do is that we can use the soft body dynamic system to create the result that we're after, okay? The soft body dynamic system is pretty easy to create. It follows a very, very similar structure and production pipeline that we saw with the rigid body dynamic structure. So let's just jump over into item mode and start making some meaningful connections between the flag and, of course, the pole itself. Now, what type of rigid body is the pole going to be? Static, yes. Let's go ahead and fire that off. Okay, got my flag pole selected here, and give me 2 seconds. There we go. Let's just run over into our dynamics, and we're going to make it a static rigid body. Okay. Now, for this one, for the actual flag itself, what type of rigid body is this going to be? What type? Active rigid body, right? It's going to be an active rigid body. We still apply the active rigid body tag to a soft-bodied object, same way as we did before, okay? Active rigid body. And let's go over and explore all of its dynamic properties. Because ultimately, what we need to change here is rigid to soft-bodied. There we go. Let's play our sim and see what we get. There it goes. Let's stop it. And I love it. If you look real carefully here, you can see that everything is actually working and behaving the way it should. Look at the deformation of the flag next to the pole. Woo! It actually touches the little chain links there and begins to deform. So we know at the very least that this is working. However, what isn't it doing? Staying there, right? We want it to be pinned kind of to that pole. And this is one of the cool things about soft-bodied objects, especially when we're working with clothing, is that we can anchor it to other objects in the scene, other rigid body participants of our scene. So let's just do that real fast. I'm going to select my flagpole first. Then I'm going to hold down my shift key and grab my flag. Okay? Now, where we're going next is back over into our toolbar. And you can see right below the soft-bodied option, there's this big anchor. And these are going to pin these two rigid bodies together. Okay, so let's do make anchors. Anchors away here, folks. Boop. Now on the surface, not a whole lot's going to happen. And if we play it, yeah, you're probably thinking, Pat, you're awesome. You're just fantastic because that didn't work like at all. However, there's one additional thing in here that we have to change, okay? And we have to go in and start adjusting and telling the computer what part of our flag we want anchored to the pole itself, okay? Now, luckily for us, it's really, really easy to do this. So I'm going to go onto my flag item and then specifically into my lists. I'm going into my weight maps area. This anchor map was automatically created the moment bloop, we clicked on that Make Anchors button. Okay? And as you can see, it's a weight map. So we're going to go in and we're going to tell the rigid body system, or excuse me, the dynamic system, which parts we want, which part of our flag we want anchored through some weights. Okay? So I think I'm getting a little bit of my texture repeating up here, but that's okay. I think I'm going to go in and kind of make a selection like this. Maybe not, maybe just the polygons immediately around. Let me turn my wireframes back on. There we go. Yeah, all of those guys. And I'll grab the ones down here at the bottom as well. There it is. So I'm just doing some polygonal selection. That's all I'm doing. I'm on my flag. I've selected the polygons right around the opening. And I want to apply some weight to them. Now, before I start activating the weight tool, I want to make sure that I'm actually sending all of this information to the correct weight map. So I'm going to have that guy selected, right? And now if we go to the top of the screen where it says Vertex map, way down here at the bottom, we have a great tool called the weight tool. And in every sense, when we were doing our paint weighting a couple weeks ago, this is the tool that we were firing off. We were just interactively using it with our wonderful weighting tools, with our paint brushes and the adjust weights. Really, it's just kind of an extension of the weight tool. So let's do it real fast. Let's fire off the weight tool. And I want to look at the tool properties, because right now, the weight that I'm applying to those polygons is 6.5%. Let's just put it at 100. There we go. Let's actually look at the vertex map here real fast. And I don't think mine did it, so let me just go back and do it again. Shift W. Yeah, I forgot to click on my viewport to apply the weight. Do the same thing. Shift W is the weight tool keyboard shortcut, by the way. There we go. Vertex map, weight tool, clicky click. There we go. So that's ultimately what I'm after, right? I want to put a weight of 100% on the polygons immediately surrounding the opening of the flag.
How are you doing that? What's the weight tool?
The weight tool, you can find it under the Vertex map pull-down menu found at the top of the screen. So it's right there. There's the weight tool. Weight tool. Now, when you fire off the weight tool, and let me just go back and do it again for you guys, okay? When you fire off the weight tool, you set your weight, okay? And then you just left click, bloop, and it applies that weight. Here's kind of something else that's kind of neat. You can actually left click and drag and interactively adjust the weight that's being assigned to those polygons. Kind of neat. Okay. Do you have your weight map selected? Let's check it out. Another great way just to make sure that you're really doing what you need to do is to change your viewport shading type over to weight map. Looks like you've got that. Okay, so vertex map, weight tool. Keep cruising. Yep, there it is. Now I'll go ahead and left click in your viewport. There we go. Let's look at your tool properties and see what weight you're putting down. So you're putting down 0%. Let's put that at 100. There it is. Okay. So play your sim now. See what you get. Now it's up there, staying up there, which is pretty great. Is everyone able to keep their flag on their pole? Alan, what went wrong on yours? Help your neighbor. All right. Ah, okay, we're putting it on the wrong weight map. Scroll up some. Scroll, there it is. We want it on the anchor map. That one right there. Do the exact same thing. Apply the weights. Click. There you go. All right, drop your tool. Aha, wonderful. So one of the cool things about this is that since we're using a weight map to influence the quality of the anchors, you know, we can maybe even adjust some of this a little bit more as well, right? Let's try this. Because I don't like how when I play the sim, it just immediately all collapses, right? Let's go in and start making some adjustments here. You know, maybe what would be best before we start making these adjustments is see if we can get it to kind of fly in the air a little bit, as if the wind's kind of pushing it around. And this is one of the cool things about the the Moto Dynamic system, is that we can add in these influencers to create some pretty awesome effects. Okay, so let's just do it real fast. The bottom here, let's add some wind. Yeah, if you look down here at the bottom of your scene, the wind influencer is going to be placed at the origin of the scene itself, right? Play your sim, see what happens now. We're going to have to make some changes here. It's going to take a second. Yeah, there we go. Look at that. That's kind of cool. It's blowing my flag up now. Watch this. This is kind of neat. I'm not going to stop my simulation. I'm just going to let it go. And let me select my wind force, and I'm going to rotate it. There we go. Cool. Looking good. Looking real good. Now, if you look at the wind properties, you can start increasing and decreasing its strength, its velocity. You know, you can start tweaking and customizing how this wind is going to be influencing and blowing your flag around. Pretty great. It looks a little paper thin, though, don't you think? Yeah, definitely. So we're not done with the tweak phase yet. Adding this wind is just step one. And bonus points goes to anyone that can actually rip the flag off the pole. Oh, hell yeah. Yeah? Do like hurricane force wind over here? Oh, did it. Yes. What did you increase your velocity or your strength? Strength is like at least 1 million strength. Okay, that's fun. Yep. So you can do some really neat things here. Let's stop the simulation for a second and return to our flag and make some adjustments to its dynamic information. So we still have to go in here and tweak a couple things. I think for me personally, I'm going to go in and make the weight of this just a little bit more, okay? Because it feels a little light for me. Flags are usually kind of heavy, especially big ones. So let's change its local mass. Let's make it 10 pounds. Let's see how that effect changes our animation. Yeah, that's a little bit better. We're getting there. We're getting there. I like it. Let's stop the animation. Let's make it 20 pounds, and I think that's probably all that I'm going to do. Yeah, now it's definitely feeling and folding as though it's much, much heavier, right? You don't get a lot of those small little micro movements as we were seeing before. It's subtle, but it actually plays a big role in establishing the correct movement for our object. Now, if I wanted this thing flapping in the wind, what do you think I'm going to have to do here? Just increase the speed of our wind, and I'm going to increase the velocity. Let's put it at 4 meters a second, and then fire off the sim again. There we go. Dun, da, da, da. So there's a balancing act that we have to play here between the speed the velocity of our wind and then the weight of the fabric, if you will, in finger quotes, that we're trying to create. Okay. In addition, there's also some other stuff in here that we can do to make it a little bit more, I don't want to say controllable, but that will influence the final effect itself. If we return to our flag and specifically go into the dynamic properties of that flag, we have a category of options at the bottom here called soft body. And there's some things in here that are really important to look at, like the stiffness bend, okay? This is going to determine how rigid your soft body is, okay? The structure, is this how much of the original shape it's trying to keep, okay? When it's at a very high percentage, it's just going to completely bend into form like a piece of paper. So if we were to lower the structure, for example, not to 8, I'm all zoomed in. Yeah, I'm all zoomed in, so it's going crazy. Let's put it at like 50% or so. Yeah, different. Let's also turn on self-collisions and see. This is probably going to kill the performance. Yeah, it just killed the performance. Oops, and it ripped off. Yeah. Let's put this back to 95. And I'll run the sim just so we can get a little bit more real-time playback of what the animation is going to look like. Sometimes those errors that are caused by the computer just managing too much information, so it just pops off the screen. Run the actual simulation, cache all this data, and you'll probably more likely get a different result. Okay? Yeah, it takes a couple minutes, but that's okay. Really, the big question is, do I want to commit to waiting for this thing to finish during class? Yes. We'll see what we get. These advanced animation stuff, it takes a couple minutes to crunch the numbers. It really does. Okay, there's a lot of math and computer science going on in the background to get us to do this. Bum, bum, bum. 27.3%, 28.1%. We're slowly churning through it here. Now, this exact same soft-bodied system can be applied to basically any shape. I think I did it with a donut last week or a ball. So we can turn anything into a soft-bodied object. It really just is as easy as going in and clicking that button. There's not a whole lot more to it. What turns into the challenge is really kind of managing all of our soft-bodied dynamic properties, all of these jazz down over here. This takes a healthy amount of experimentation to get right. It's not easy, but that's just kind of the system that we have at our disposal. Okay. Now, this soft body stuff can be used in a variety of capacities, and I wish this wasn't taking so long to compute because I want to show you the next thing, okay? Because flags are fun, but not every animation is going to need flags, okay? However, we can use these soft-bodied systems to help us model in every sense, okay? And this is really where I kind of enter in and start using the soft-bodied dynamic system. Is we can do tablecloths in like that, right? We can do drapes like that, right? We're going to have towels in the bathrooms like that, right? We don't want to have to go in and model drapery. If we can use our dynamic engine to get us there, yeah, all right, that's what I'm all about. Yes, sir? Oh, you broke it. You really broke it.
I know. This disappeared, right? What's the command for that?
Well, it depends on what you hit. You may have just hit this key. Maybe not. Maybe that one. It was that one. Yep. Yeah, that's the maximize button. The 0 key on your number pad is going to maximize whatever window your cursor's on. Yeah, I guess I'm not saying that you're undisciplined, but I'm so disciplined to not even touch the number pad. Yeah. Yep. Okay, I don't want to sit and wait for this anymore. This is taking way too long on our little IMAX here, so we'll just keep going. Trust me, and I hate saying that, it's awesome. It's really kind of neat. Of course, now it's going to make me crash. Okay, great. All right, so this is pretty neat. Oh, one other thing before I walk away from the flag. You can add some really neat things in here, like turbulence or a vortex. Let's do a vortex. Yes. So now we got wind and a vortex in here. Let's see what we get. Yeah, that's cool. Let's turn off our wind force And I want to turn off on the flag the self collisions just to give us a little bit more performance. Yeah, that's cool. Now it's kind of hard to see from here, but what the Vortex is doing is actually creating kind of like a little tornado in the center of our scene, and that's kind of a cool result. I think that's actually more of a compelling result than what we had with the wind influence in the scene. So there's different influences that we can put in there that's going to give us a variety of results. Have fun with them. It does take some experimentation. It really does. Okay, the Vortex is fun. Turbulence is also kind of fun because this is just kind of like a random noise. Imagine if the wind is a linear push. Okay, turbulence is kind of the same thing, but instead of pushing it in a straight direction, those little push rays are going like this, just kind of like every odd direction. Okay, you can get some pretty entertaining results from that as well. Let's put one in. Let's turn off my Vortex. Yeah. That's good too. All right. Let's go ahead and stop it. And I want to show you something else in a new scene file here. I think I'm going to just put in a cube, and I'm also going to throw in a plane. Okay. I'm going to show you how easy it is to do drapery real fast. So the cube in every sense is going to be, here, let's make it a little bit more real. Instead of using a cube, I'm renowned for using basic simple shapes, but let's use something a little bit more direct. Let's actually get a table. Okay, it's not in this one. Household, interior, oh, no, that's tabletop. Furniture. Tables. Here we go. I want to put a tablecloth on that table right there. Okay. There's my table. I want to put a tablecloth. I got company coming over tonight. You know, I like to impress my friends. Let's make a tablecloth. Now with this, what we're going to need here, that's a little too big. Make it a little bit smaller, going that way. Tablecloths are kind of rectangular in shape, right? I remember when I was first growing up, I had to buy a tablecloth, and I learned pretty directly that there's different tablecloth shapes. I know nothing about tablecloths, but now I do. All right, let's go back into our setup. There's one thing that we have to do in order to give us some really good results on our tablecloth, and that's divide it a number of times. The more polygons that we have on our soft-bodied objects, the more detail that we're going to be able to create in the actual simulation itself, okay? So low-resolution geometry is going to give you low-resolution results, but don't go crazy with the high-res stuff too. But in certain situations, you're going to want a high-res, and I think I'm just going to do that. I'm going to subdivide this, Shift-D. I'll do this one more time. There we go. That's enough polygons. It's a 4,000 polygon tablecloth. Okay. All right. Let's make these. Let's set up our sim real fast. So here's our tablecloth, or our table. This is going to be a static rigid body. The tablecloth is going to be and you can just do soft body too inside the toolbar. Okay. There we go. Let's play the sim, see what we get. It fell right through. Mission accomplished, right? That's just beautiful. Let's see what's going on. Let's look at our dynamic surfaces here. Let's do mesh. Maybe, there we go. Wonderful. It is. It's alive. Okay. So what you can do here, and let's do this. Let's change our sequence settings to, let's do 300. I'll double the length of my sequence, okay? And go, I'm also gonna just go into my tablecloth, and let's make it a little bit heavier, because it's local mass, so let's make it a 10-pound tablecloth. And now what I'm going to do is I'm just going to run the sim itself. Let it cook for a second. Hopefully it won't take as long as the last one did, Because what we can do at the end of this is then freeze this simulation data, and we'll just get a model. It will be completely disconnected from the actual sim itself, and we'll just get geometry that we can use like any other model at that point. And it's all made with the simulation instead of me having to go in with my sculpting brushes and deform it into something that looks nothing like a tablecloth should, right? It's pretty neat. How we do that is in the actual dynamics menu itself. We can bake all of this information and then freeze the geometry. Of course, it's taking forever. Here, I have an idea. Let's freeze let's simulate just frames 299 and 300. Just that one. This may break it. That's okay. Then if we go, did it do it? No, it didn't start the sim until 299. Poop on you. Let's see if I can force my hand here a little bit. Instead of having it fall for a number of frames. Okay. It just bounced off the table. That's not going to work. It's an awesome effect, though, right? Is it good? You like it? There we go. I mean, try modeling that, by the way, right? Eventually, after a period of time of the sim running, it will kind of iron itself out. Okay, and that's kind of what I'm going for. There it is. It's right about ironed out. Now, unfortunately, I don't know what frame that is. But when you're done, if you actually compute the simulation, you can go up here and, where is it? I always bake dynamic transforms, okay? When you bake the dynamic transform, what it's going to do is that it's going to basically create a keyframe for every frame of the simulation, and it's going to permanently save all that sim data in each frame, okay? From there, so it's kind of a two-step process. From there, you go geometry, freeze, okay? And then that's going to permanently, preserve all those transformations on the polygons itself. It'll remove all the keyframes, and you'll have what you have. You want to make sure that your playhead is on the frame that you want to kind of bake and preserve, because that's the frame data, or the frame data is going to be what's frozen into the geometry. And it works really well, actually. It takes a little bit of time to run the sim, but man, it's pretty quick. The results are pretty. You'll do it a whole lot faster than modeling, and the results are going to be pretty stellar as well. Yeah. Okay, no problem. Good luck on your storyboards. All right. You're going to miss the destruction, Joe. I know, right? This is what happens when you leave. I know. Okay, whatever. I don't believe him either. I think you wanted to leave. Let's see. Did I save it? No, I didn't save it. Okay. So let's have some fun for a second here. This is actually incredibly entertaining. The last thing I want to show you guys before I kick you out is some basic shattering stuff, because these are things that are good to know about inside of our dynamic engine. And shattering is a whole lot of fun. It really is. And we can do some pretty entertaining and fun things with shatters. Okay, so I've just created a new simple little project file here. And I think just real quickly, what we're going to do, let's do this. I'm going to create just a very simple column. There we go. Oh, maybe not. Oh, I'm too awesome today. Moto's just choosing not to work. Awesome. That's good times. See, even Moto is telling me, hey, Pat, you know what? It's the end of the week. It's Friday afternoon. Why don't we just go home early today? No, we got to look at shatters, man. Shatters are awesome. right? Does anyone know where Joe was going? Wherever Joseph Fry was going. Yeah, you do know his name's Joe, right, Mr. Duffy? How about that, huh? You think you know a guy, and then it's like, oh, wait, his name is Joe. I thought his name was Fred. I'm just giving you a hard time. All right, so we're going to call this just the simplest little column ever. Because I'm a 3D modeler, it's got to look at least something like a column. Okay, that's the bottom half. Let's mirror this thing. I got my snapping engine on, and this is the cool thing about having that snap engine on is that I can just bloop along the y-axis, and now I'm done. Okay, there it is. So there's my cool little column. Let's destroy this thing, right? You guys ready for some destruction? All right, let's do it. Let's call it column. All right, let's run over into our setup tab. And there's actually a number of ways that we can make this oops, wrong button, excuse me. There we go. All right, so there's actually a couple different ways that we can destroy this little column here and shatter it into a million little pieces, okay? There is the pre-processed way, and then there is the procedural way. Let me show you both, okay? And I want to save my scene before I go too much further. Just so I don't have to do this again. Of course, our column, our plane is going to have to be a static rigid body inside of the scene itself. Now, we can pre-process the destruction of any item that we want, okay? If we're in the polygonal selection mode, we can cruise up to the top of the screen. Some of you guys have already found this, and it's pretty neat. Geometry, mesh, shatter. And we have 5 different options, 5 different patterns, if you will, that we can apply to our mesh and have it automatically get shattered. It's pretty neat. So you have uniform cluster, radial, splinter, and source. And honestly, I don't know what source is. But let's look at some of the others. Uniform is just going to go through and try to make it into a whole series of little pieces. And the way that the guys and gals down at the Foundry has done this is pretty cool, because not only are they going to create pieces, but they're also going to create a new material group for the inside of the actual shattered piece as well, which is pretty neat. Okay, let's do it real fast. There it is. So it's gone through. Yeah, it's all algorithmically done. Okay, and if we take a look at it, these are now pieces. Absolutely. So this is just geometry, okay? And what's cool about this, as one might imagine, is that we now can make all these shards a participant of a rigid body system. Let's turn off the original. Let's play it, see what we get. Okay? So you can pre-process all the shatters, which is kind of neat. Okay? I like that very much. If you experiment with all the different patterns here, you can actually get some really neat things. Radial is kind of fun. Let's see. Yeah, the center is, there it is. There's the center of the shot. It's really cool. I'm going to undo it. Let's see if we can raise up the center of our radial shatter. Let's see. Is it going to? It's going to do it probably at, where is it? Radial rings. No, we want it along the z-axis. Let's raise it up a couple feet. No, I think it's going to do it at the center point of that object, which is down there. Let's confirm that. Here's the item. Its center point's way down there. Let's change the location of the center point and see if we can get the shatter to fire off differently. The radial shatter is kind of neat. Yeah, there it goes. So it's going to shatter at the location of the center point itself. So if you're doing like a bullet shot or something like that, right? an impact in a specific area. The radial one's pretty neat. Tweaking the settings here will help. Yeah, all of these guys. Rotation, let's do like 15 degrees. Oops, I didn't mean to hit return. But yeah, now we're getting something a little bit different, okay? So there's a lot of options, a lot of commands that we can, or a lot of channels that we can influence to shatter our objects a little bit differently. And this is just so much fun for me. Because now I can go in, make them all active rigid bodies. That's fun. Yeah. So that's a little different, right? That takes some engineering. We'll have to create what's called a constraint modifier to hold all these pieces together and then animate the constraint modifier basically breaking and letting everything fall apart. The constraint modifiers are kind of like glue that holds everything together, and then we can say, okay, release. It's a little bit of, it's kind of a complex setup, but it is there. I'll let you look in on that by yourself. It's called a constraint modifier. It's pretty neat. All right, so this is a really neat tool for us. I think if you're doing some modeling, this is a fantastic way to very quickly get some really good like rubble or some things broken. But it takes some pre-production, right? You gotta like pre-process all the shatters, break them, freeze them. There's a lot going on. We have another thing in here which is kind of neat called procedural shatters. Let's do that. Go back in time a couple steps. And this does the shatter at the item level, and it's right there. And this is going to shatter our object the moment we hit the play button. So it's not going to pre-process all this jazz. Let's do procedural shatter. We'll leave all these settings as is just to kind of see what happens here. The type of pattern is going to be impact. Let's see what that gives us. Oh, you know what? That's my fault. My fault. I forgot to do something. Oops. And of course it's going to crash. It's most likely going to crash. No, it didn't crash, which is good. Nope, wait, we have a heartbeat, but maybe not. Aha, wonderful. So the thing that I didn't do was move it up, because the procedural shatter, let's put it at an angle too. This is cool, because now we'll take advantage of that impact pattern. Let's run the sim now. This is not going to go well. It's going to think about it for a second, because now at that moment in time, it's shattering my column and trying to figure out how to slice it. It's applying all the active rigid body tags at the exact same time. There it is. Isn't that cool? Yeah, that's kind of neat. And because my column was at an angle, it actually sliced it based off of its impact angle, which is neat, right? It didn't do like the slicing of the shattering like in the center like it did for the radial one. The pieces that initially hit the ground plane are the ones that got shattered first and at a much smaller. Let's change the pattern, because this is just a lot of fun. Let's do uniform and see what we get. It's going to take the frame of impact takes a while to go. Yeah, of course. Let's see what we get. I'm excited now. If you look at all the parameters in here, you really can customize how this shatter is going to work. The ones that I really focus in on are the braking force. Okay, so if you wanted to simulate something being really heavy, like a stone wall, increasing the braking force is going to help. In addition, let's see, the pieces per mass cubed. Okay, that's going to determine how many individual shards are created at impact. Okay, don't go crazy with it, because the more pieces, the longer. As you can see, it's still taking some time to render all this, even just to process it. But it's some fun stuff. It's really fun, actually. Okay? All things that we should and can use in our animations going forward. So as you start to conceptualize what your final project is going to be in this class, Think about some of these awesome new additions. If you want to destroy something, we can do that pretty easily here. We looked last week at how to break down a wall. We spent some time talking about dominoes today and really taking advantage of our rigid body dynamic system. We've shattered something. We've made cloth. The dynamic engine inside of Moto is pretty powerful. We can do a lot. It takes some engineering, and it absolutely takes some time, but these results are attainable right out of the box. Cool, huh? All right. Questions, comments? What'd you get? Huh? You rendered your flag. Look at you, Mr. Overachiever. I'm joking. And you know what's really cool about those soft body dynamics is that we can absolutely still subdivide them as well. Hitting that tab key smooths everything out. Yeah. Yeah, we can definitely start putting it all together. Okay? All right, we'll see you guys next week. Remember, do your storyboards. I want to see them for next week.